in a few minutes, but I am starting the recording and everything, that we don't forget about that. But we will start just after 9. Hi, Bronwyn.
Morning, Joan. How are you?
Good, and you?
Good, thanks. I'm just going to be here in the background observing today.
Perfect, no problem at all.
Thanks.
Okay, so we can give a minute or two still, but we can also start chatting on the way in preparing for your exams. So today it's only a session for DSC 1520, so we'll do it a 2-hour slot today. We had the 1631 last night. So 1630 the recording will be available early next week. Yeah, so, but I also think if you're part of a group, you can sometimes download the recordings in some of the file settings as well. So if you need the 1630 earlier, it might be already in some of the files. Okay, so this morning, we'll continue with where we left off last week. This morning we will basically start looking at your nonlinear functions, and most of them will be quadratic equations that we will be looking at, and then as we continue, hopefully we'll be able to look at chapter 5 as well, which will then also include some of your differentiation theory, and then hopefully by next week we will be able to do inference and those kind of things. Let me quickly just, on my calendar, I still have that you are writing. I just want to open my calendar. My side, it is taking some time. Around the 23rd, I had it, I think. So just want to make sure that it is still, yes, the 23rd. So hopefully it is still the 23rd. So that we will, maybe next week we'll see if we can have somewhere in the middle of the week a session as well, and then Saturday nearly have your final. Sure, that feels so close. Your final exam prep before you write on the 23rd. So we'll communicate about a midweek session next week, and then Saturday the final nearly session, and if needed, maybe the Monday before you write. But sure, you don't really want to have a session on Monday when you write on the Tuesday. So next week, Saturday, will be the last session. So again, we'll make it a 2-hour session, but I will see how we can squeeze in another session within the week. Okay, so with that in mind, that you're still writing with 23rd, let's get going. So basically, when we look at nonlinear equations or nonlinear functions, in the chapter 2, chapter 3, when we were looking at linear functions, we also had your linear programming. So it would have been looking at a straight line, you would remember that then from that straight line, you could do a few things. So you could have had with two straight lines intersect, and that would have been your equilibrium. You could have had other instances where you would have had things that you need to work out your um, producer surplus, your consumer surplus, those kind of things. That will also still happen. Let's just see if we can, if everyone can just put off their videos, please. um, cool, thank you. And then that we are going to do in the linear functions as well. So basically replicating a lot of that in the non-linear functions. So if you look at non-linear functions is basically anything like uh, a quadratic function, like and how to pronounce it, um, parabola or parabol, um, is this function where you basically have one turning point, and this turning point is at that point. So when we do differentiation, actually the straight line from a differentiation that you will get, so that in the next chapter will be the line that touches that quadratic function. Um, so the questions that you will get on the nonlinear functions, and we will go through a few previous examples, will be very similar to the ones that you had in the linear function. So it will, instead of the normal demand function um, and the normal supply function, you will now get a total revenue function. Um, and that total revenue function will always have a quadratic in it. Um, and what they will then ask you to do is to look at the two quadratic functions, and most likely what will be the values for yourself to make sure that that quadratic function is in equilibrium or not. So exactly the same that we did with the linear functions. Nompilo, if you can just please switch off the video, that for the bandwidth and everything, that when we later post the video, thank you. Okay, so the standard formula for a quadratic function is where we had for the linear function, we always had mx plus c. So very similar in a sense. We still have the c that will be your cutoff or your y-intercept. So that stays exactly the same. We've got your bx. In a sense, we'll look at that, and then you will have a quadratic with that. So we will then use that function and some of those to answer certain things. So I think the important thing that we, and I'm just going to draw something quick here. It's not on scale or anything like that. So that is your C. So as so that will be your C, where the cutoff is. You will then need to do some work to get to your X values, but there is a formula for that. So to get to that X values, you will use this formula, which is again given. It is on the formula page that I will supply you in the week as well. So you have that formula that you can always go back to calculate your x-intercepts. So it will calculate that value and that value. And the last thing that you will need to work out is a turning point. So basically that value there will be your turning point, and I'll show you also how to do that. But for that, there's also a formula. Um, so nearly important quadratic function, very similar to the linear function. The only extra added information is that somewhere it has a turning point which created that it looks to the quadratic. Okay, so with this in mind, there's a few nearly previous years questions um, that we quickly can go through. Also, if you have any questions that you are not sure of, that you can always post it onto a WhatsApp group, and we can put that into a session in the week to go through that. So again, please WhatsApp me or email me. So I think really with this last week nearly that you have available, please use that opportunity, so that any questions nearly please send it to any one of those contact, that we can sort out any of your questions that you still have. Um, so for the guys joining during the session, we will try to put in another session somewhere next week during the week. So it will be an evening session. Um, I will just check when my load shedding starts. So it can be or 5 o'clock session or 6 o'clock session for a 2 hour session. And then we will also have a session still next week, Saturday, because according to my calendar, you are writing on the 23rd. Okay, so let's look at what they give us. So they talk about total cost, they talk about total revenue. Remember from your total revenue and total cost, so where your income is exactly the same as your cost, that is where you basically will have an equilibrium. So they tell us the firm's total cost function is given as 4 plus 8q minus q square, and the total revenue is that, where x is the number of units produced and sold in thousands. How many units sold should be produced to maximize profit? Okay, this is interesting. As I always want to give you tips, and since this was pre-time at none of the above, so you don't have options of none of the above anymore. So if I look at this, I would have nearly said between 7 and 7,000, just because you need to remember the answers should be in thousands. So my mind is just nearly going into that direction. But let's see. But remember, your end number that you get, you need to multiply it by 1,000 so that you know that it is in thousands. So again, the small catch in this. Okay, so let's see if we basically solve the two equations. So that's on the one side. On the other side, we've got 50q minus, I still don't know why this is happening, that my disappears, but it is happening across the board, so it might be on my side a Microsoft issue. But basically we have a one total revenue that's equal to the total cost. Or the other side around, this was total cost equal to total revenue, and we need to solve that. So as always, I love, or I don't want to work with negatives, so I would rather want to move all the minus to this side. So to get rid of a minus 4q to a power of 2 on your right hand side, I need to add it on both sides. So this side, it will become that, just so that we still have that minus q. So those two will give you 3q to the power of 2. Then we need to take that over as well. So plus 8 minus 50 will be minus 42q, and then the only thing left is plus 4. That feels weird. Did I miss something here? Anybody else? Does it seem correct? Did I miss something? I was hoping it will be an easier way to get to the 42. Sure. 4, 8.
That as well.
Yes, Robin? You can say again.
Sorry, can you hear me?
Very soft, but I can hear you, yes.
Sorry. No, I said I also got that, but it's very difficult to factorize that.
Yes. So you then need to use the formula, I assume, which is, so normally we would then need to use this formula. Normally it's easier that you don't, uh, let me get that. That's why I was nearly like, it can't be, because it should normally be easier to do it. So again, this was assignment, not exam. Exam will more likely be in line that it is easier to work with. So let's quickly then replace the values in this. So I just want to mark with a different color. Remember, we've got A, B, and C. Okay, so when we then work out X, we've got minus 42. plus minus the square root of, and that is nearly, so minus 42 to the power of 2 minus 4 times A times C. Yo. Divided by 2 times A, which is 2 times 3. Okay.
Sean, I'm
Yes.
wondering if it wouldn't be easier to do for this one to do a marginal revenue equals marginal cost and rather differentiate it.
Sure. Okay.
Because this is getting very complicated.
So then you would have,
You would have had to work out marginal revenue and marginal cost and then get that to equal each other. I think that was differentiation or integration. I can never remember.
yes. So let's, and now that you mention it, so let's quickly draw this line.
Because
So
they're
it is
saying maximize profits, right?
maximize.
They're not
Yes.
saying break even point.
Thank you. Okay, so let's say it is something like that. So to maximize profit, what do you need to do? So you will actually, and yeah, thank you for that, Robin. And it shows you how I just went into wanting to solve for X. And that's why when I got here, I should have actually said to myself, am I doing the right thing? Because we are not solving for X, we are looking how many units we need to produce to maximize profit. So we, up until here, it was right. But then the next step is what we would have done in the next chapter, is how do we maximize that profit, is actually just to differentiate on this line. So you have that, the place where now I'm erasing instead of, so like I said, when I drawn it, the place where you will get the touch point is that place where you will have it. So we would have then said differentiate it. When we differentiate, remember you have a free. You have a free, you take the 2 to the front. So it is 2 times 3 times q. Here, remember there's a 1, and remember what happens. Take it to the front. The next step in here will be 2 minus 1. So we basically have 2 times 3 times q, which will be 6q. Take that to the front, multiply. So minus 42 times 1 is minus 42. Here you would have had q1 minus 1. what is Q1 minus 1 is equal to Q0. And what is Q0? Q0 basically is equal to 1. So remember from one of the factorizing rules, so anything to the power of 0 is equal to 1. So when we do that, that disappears, and that needs to equal to 0. Okay, so 6Q will be equal to 42. Q will be equal to 7. Okay, then remember this, that you need to say it is in thousands. So yes, it's 7Q, but it is 7,000. So your answer then should be only option 3 and not option 1. They could then ask you on this if you put 7 back to any of the questions. So there might have been a follow-up question to this to say, but what is your total cost or what is your total revenue? So that you put the 7 back into one of the formulas. And it might even be that that number is, strangely enough, might be that answer. If you put it back, it nearly seems like it can be, or it could be the 252. So that if you actually went a step further, it could have been your answer. Okay, so very important when you do this that you read the question. You could see here, I was already in my mindset, I wanted to solve X. That was nearly my goal. And it never ever said anywhere in there that I must do that. So again, I know it's difficult when you do online because you can't highlight anything, but nearly even if you write on a paper, um, and you write how you're going to work out question 3, write on it that what they're actually asking. So maximizing profit, that you know what you need to do, so that you don't go in a tangent like I did to get to X, because that's not what's needed. Thanks for that, Robin. And I think that is also the other thing, when you get to this point and you see it's going to be difficult to solve X, you actually should already know that then you're doing the wrong thing. In the exam, you get very limited time. So it is very seldom that you will get an answer that you need to go and use that formula nearly, unless it is only one of those questions. But there's normally a few of these, so very seldom you will get that long answer that you need to work out. So actually at this point, I should have realized that I must not work out the X's. Okay, everybody happy with that? So very important when you read the question from the beginning, that you really need to see what you need to do. Okay, so now we are going back into a demand function. So they're asking us, the demand function of a firm is Or yes, Robin.
Sorry, John, sorry. Before you move on to the next
Yes.
section, though, I must say what was actually very cool about that is I never actually thought to first do total revenue equals total cost and then simplify it and then differentiate because I usually do it separately and then plug it in together, but actually that's way more efficient
Yes.
and
So
easier, actually.
yes, because if what did you get if you actually did it separately? Did
I
you
can, I
still
haven't
get
tried it, but
okay?
I can
Because
try
you
it
will
now.
probably not get the same answer
Okay.
because
I think you should. Why? Why wouldn't you? Because you would still get what 50 minus 8q, and then you would get 8 minus 2q, and then if you put that together, then should be, I don't know, similar. Would you not still get 42?
7.
let's quickly check. So I'm gonna write it here on a piece of paper first. So let's say it was 8 minus 2q, and the other side was 50 minus 8q. Okay, you actually would get the same. Okay, so that's interesting. So by let's draw this. So I just now need to so say that was our graph. Both of them are negative, so they're going down. That's going through 4, that's going through 0. So let's say the 1 is going through there. Phew, I'm just now, and the other one went through 4. So if it was something like that, so I calculated that point with with this and then differentiate on a straight line because that's where you gonna maximize what you did. You said, okay, where it's actually you said where it's gonna touch that one and touch that one. It is exactly the same.
Yeah, I never thought of doing it that
Uh,
way.
Okay, and I never thought about the other way because
Uh,
but that's fascinating actually. So and it just shows you how the linear and the quadratic, especially for these functions, are so much similar. Yeah, so whichever route is actually the easiest for you to do.
yeah,
Yeah, because I would not, I would have gone straight to actually to get that point and then to differentiate around that. So that's quite interesting. You'll get the same answer, which is actually quite cool. Okay, so two ways of doing this, and both are right. And just remember in both of them that when you get to 7, that you need to say it in thousands. Okay, so let's look at the next one. A demand function of a firm is given by that, where P and Q represent the price and quantity. At what price is revenue at a maximum? Okay, so tell me what is your total revenue function? Just from um, the standard function. Okay, so your standard function would be total revenue Okay, thank you. So your total revenue will be price times Q. Okay, so that's the standard. So firstly, when you look at this and you got that, it would have been, oh, seems like I'm missing something, but actually not. So now you can do two things. You can say, well, I've got Q, so I will replace Q with what is in there. And by that way, I will get a quadratic function. It will be 9p times 90, which is 90p, p times that, so it is minus 1.5 p to the power of 2. Okay, so that could have been one way. You could have also made p stand on its own, but then we are making the q a bit more difficult for you to work with. But you could have done that. So if that was a different value in front of the p, you might have just said, okay, but let's, instead of replacing q, we can replace p and do the same thing. Okay, so we basically can then work out your total revenue is this function. Then we go through the same process. So how do we maximize total revenue? It is where this point for differentiation is equal to 0. So we will basically then just do the same process. So remember there's a 1. So 1 times 90 is 90. Then it becomes P1 minus 1. So the P drops away. On this side, it is 2 times 1.5. I think it is 3. Just want to make sure. Yes, so it is 3. P, so it would have been 2 minus 1. So it is P to the power of 1, and that should be equal to 0. Then I like to have all the P's so that it is positive. So 90 will be equal to 3P, and then your price value is 90 divided by 3, which is 50. They're asking us price, so that is the option there. Option 2, they could have asked us also what is the value of Q, so that we needed to put in it into that formula. So then 1.5 times 30 would have been 45. So 90 times 90 minus 45 would have been 45. Just if they ask us to work out Q as well. So with your formula, or with the answer that you have, go back to your original. Always go back to your original to put in the 50 back into your original. So 50 times 1.5 will be 45. So 90 minus 45 will give you the Q value of 45. Okay, so then I could have also asked you what is your total revenue, which you will then have as 30 times 45. So just if they ask you that as well. So just nearly want to make sure that anything that that they could have asked around this, you can work out. So with just giving that function, they could have asked you to work out the price like they did. They could have asked you to work out the Q, or they could have asked you to work out your total revenue. So just be on the lookout for these types of where they give you just one bit of information, and sometimes one forgets that it is enough. Okay, so very unlikely might happen, but very unlikely. But if it happens, it will just happen in one or two of the cases, is that you could have had to work out the P in this instance, and then there's a follow-up question in the exam to ask you to work out all the quantity or total revenue. So you might have seen it in your last assignment. I think there was one or two questions that they gave you information and it was based on more than one question. Again, it can happen in the exam as well. So again, how I would prepare for the exam, because and just give me a bit of feedback. Was your questions in your assignments, was it nearly linear? So when you're done with question one, you went to question two, you couldn't go back to question one? Was it like that, or could you go back in your assignments to previous questions after you finished it?
No, it was just given in one page, so you could go back as and however you wanted.
Okay, cool. So it's not like the stats one where you can't go back. Okay. So then what I would normally say is, as you do, and if you are writing something out on paper, just make sure that you have it for if there's a next question. But then if you see everything on one, then it is not too bad. When you can go back into, and I thought it was different for DSC than stats. So at least you have that functionality, so that you don't need to worry. Okay, cool.
Sorry, John, I'm not sure if the exam's gonna be the same though. Obviously,
See, it's
should be, but I don't
it
know.
it's the exam should be the same as your assignments is, but it might be if somebody can find out, or I can check in your study, or if somebody can send me some of your TUT letters, and if you have the exam letter or something, if you can just send it to me, or any of those things. Did you have a mock exam?
Yeah, that was how the mock exam was. It was just one page, and then you went down the questions.
Okay, no,
Very
but
easy.
that is when how your exam will also be.
Okay.
Because the one thing I know that's different in your decision sciences versus the stats one is, stats, you start off question one is chapter one, and it goes to last question is your last chapter. Decision sciences like 15, 20, and 16, 30, you can have a question of the last chapter as the first question. So there is no, it is mixed up a bit, so that you can sometimes get confused. Like what we're doing here is we're starting off with a lot of quadratic equations, but then we are actually doing the next chapter. So a lot of your quadratic equations that you will work with, in the end, you will most likely do a differentiation on it. to work out one of your total revenues or one of those. So even though we're nearly now looking at these as quadratic equations, it is with a specific reason. And I think that is also going to happen in your exam is don't expect that you it's going to be first all your linear equations, then quadratic equations, then differentiation, then integration, then it will be mixed in between the different questions. And I assume your mock exam was like that as well. Could you were you able to download the mock exam at all or not? Just that one has a view on the type of questions that is. So if anybody could have downloaded it, and they can share it as well, it would be great. Else we will just manage by other questions that you can send me. I've got a few previous exams that we can also go through the next time. Okay, so when we look at question 7, um, they tell us find the equilibrium price and quantity for the demand and supply functions. Okay, so now we are actually finally at one that we will work out just for normal x's, and then to see what it is. So we need to work out equilibrium price. So let's put the two together. That is supposed to be supply and not a 8. So there's probably only one question in this set that is really looking at pure quadratic equations, but that is also fine. So we can just put the two together where the touch point will be. That is where it will be equilibrium. It's interesting. So by these answers, so just purely by the two sets of answers, very important. So look at that. So you will see there's a 4, there's a 4. So one of these answers might be 4. So very important that we know that it's a Q or a P. The same in this instance. So you could see that it is probably going to be one of those two or one of those two. So again, when you look at it, just be very careful when you work it out that we make sure that we have the right one that we're looking at. Okay, so let's get to the Q's. Again, I would put everything to this side so that I have everything as positive. So minus Q, to get rid of this minus Q, I need to add on both sides a Q. So it will be 2Q to the power of 2. Then on this side, it was minus 10. I will move it over so it becomes plus 10. So it's actually then plus 24 Q, and then 150 on this side. If I take it over, it becomes negative 150. So negative 150 plus 22 is minus 128. Okay, we will probably be able to factorize this, but first let's just see that there's a 2 in both. So I will first just like to get rid of the 2. Again, just to make it a bit simpler, it is plus 12q minus 128 divided by 2, which is 64. Okay, so now let's just make sure. Okay, so there is now you can, yes, thanks, Bronwyn. I think that is very important to the guys, just what looking at the chat. If you log in with your UNISA credentials, you are able to look at what's in the chat, get access to all the things that are on the Western Cape site. If you logged in as a guest or as maybe your work email or something like that, you won't. So again, if you need to get access, just send Bronwyn and the team the email. I think I've got it here, so I will just quickly copy it in. Just the email also on the CTN TAT, so that you can get access to all of the things. Okay, so let's just go back to this one. So how I would look at it, so for me, it feels like this needs to, before we go to that other equation, I think we might be able to work with factorization here. So what I would look at is what times what gives me 64. So if you look at it, I think 8 times 8 gives you 64. That won't give you 12. So what else can give you that? 64 divided by, okay, so there's a nice one, 16 and 4. Okay, so the two that I'm going to use is 16 and 4. 16 times 4 is 64. So we will have on the one side 16, on the other side 4. Then just we need to have a positive in the middle, so it will go with the biggest one. Negative time or negatives times a positive will give us the minus 64. So the two values for Q will be minus 16 or it will be 4. Okay, so now when you provide something, you make something, you can't have a negative quantity. So interesting. So yeah, it was 16 as one of it. So we know the quantity is equal to 4. It can't be 16 because it's actually negative 16. So option 1 is the correct one. We can then put in 4 back into the equation. I will put 4 back into that equation. Because again, I don't like to work with negative numbers. So 4 to the power of 2 is 16. So let's just work that quickly out. So if I put it in there, it will be 16 plus 14 times 4 is 56 plus 22. And then that should be equal to 94. So let's see, 56 plus 16 plus 22 is 94, which then do give us that value. Okay, so in this instance, we looked at the formula. We needed to work out the equilibrium. When it's equilibrium, we can say the one is equal to the other one. Then we need to solve for, if it was x's, we would have said solve for x, but in this instance, we solve for q. We get two values for q. The one is not possible because it's a negative. And then because it's a negative, we can only work with a one that's positive. And if needed, we can put that positive Q value back into the original to get the price as well. If this was positive 16, you would have had that you will get two answers. So then it should have been Q is 4 or Q is 16, and P is 94 or P is 320. So if both of them is positive, they need to give you both options as an answer. Then you can't, then it's not a decision between those two, because both of them will then have been putting you into equilibrium. So if it's both positive, just then also remember that the answer should be both. Okay, so there's another one that we can look at. In this instance, also it refers to quadratic equations. In this instance, they tell us, or they give us this graph. And it's only that graph that they give you. And then they say that with that graph, you now need to say which one of the answers is the correct one. Okay, so a bit different, but let's first see if there's certain things that one can cancel out, not use before we need to do anything. So if my graph is, there it goes again. If my graph is pointing up, do I have in front of a x square a minus or positive?
Jean, this is the first time I've ever seen a question like this.
Okay. Okay, so this is one of those interesting ones that let me, I'm sure it is, oh, I have it, yeah, so, oh, I haven't added it in here. I will give you guys a guide on that, where if, depending on what way your graph is looking like, it will be a positive or negative. I just quickly want to check if it's not in the study guide. But I'll get it. So since you haven't seen it, let's not go there yet. Let's look at other points. So this is my turning point. So my turning point is probably going to be somewhere around that. So if I look at my turning point, which is represented by all of these, it seems like it's going to be x1 and some value that is minus something there, which I don't know yet. Okay, so my turning point is where x and y is going to be. X is going to be 1. I don't know what y is yet. So if I look at my turning points, that is not the option. 1, 1, 1. So any of those three could be an option, but at least we have excluded one of the things for you. Okay, so then the next one that we're gonna look at, and I just want to quickly check. So before we go into putting the minus, it looks like -1 and 3 into the equation. Okay, so we know that that point is going to be negative something. So all of those three are negative, so we can't cancel out anything there. So that is not going to help. We know that all of those points are going to be negative, so again, we can't cancel out any of those two. Okay, so when your, like in this instance, your graph is pointing upwards, whatever is in front of the x square must be positive. Okay, when it is turned downwards, whatever is in front of the x square is negative. Okay, so this is another one that, so before we go into trying to solve it, so if it's pointing upwards, positive, pointing downwards, negative. So in front of the x square, it should point upwards, so it is positive. So that one is also not one of the options. Okay, so that leaves us with one that the only difference is the middle term actually. So I don't like this. So we have two points. So x squared plus 2x minus 3, or we have x squared minus 2x minus 3. Okay, so if you look at this, what would you have guessed?
Number 4.
Okay, number 4, the minus 2x, and why would you have said that? Or is it just a guess? it's a perfect guess. So
It's yeah, when I look at it, I see as the y y side as a -3.
perfect. Okay. So when we look at this, it would have been something like this, because there is your x free, so it needs to be 3 minus 3, and on this side it would have been -1. So the -3 will be your highest, which will make that middle one the negative sign. Perfect. So option 4 is the correct one. And then you can actually, if you, we had on years ago, and I'll share that group with you guys in the DSC chat as well. I have a group from the years, and it started with doing DSC1520 about 4 or 5 years ago. And we've got now a UNISA moral assist group. I'll send that link on to you guys. But what one of the guys said there is he's not working out any of this like we did. He is using a method that he's going to put in that number that he knows is X into that formula, and if he gets that answer, he's happy with that it's that correct. So he would have said, well, let's start at the top, put it in, and we'll see, because one of them will show you that if you put in X, my answer then should be 1, or if I put in 1. So again, if you don't know, don't always know the answer, try shortcuts, and that in this instance, that's a very easy shortcut to put in the X value. If we put in the X value, you would have seen that would have been, okay, that's the turning point. So we then would have gotten to that turning point. But yeah, so there is other ways to do that as well. Let's quickly see if there is. So when we get to cubic functions, exponential, logistic, hyperbolic, there's not really in your, what will happen with cubic is most of the time you will first have that you take out a linear function, and then you will get the rest of the quadratic function. It's very seldom that you will need to work with a cube function on its own. So a lot of the times what will happen is what you will get, you will be able to take out one factor, and the rest will then be a quadratic factor. A cubic function, so let's show you. So where we had this as the quadratic function, a cube have another turning point in it. So it would have that one turning point, and then it will have another turning point in it. So your cubic function normally have two turning points, but you will nearly see every time that you can first take out something, and then you're left with a quadratic. Okay. Also, if you ever get the cubic function, and that's why it's also nearly important when we do differentiation. When you differentiate the cubic function, put it equal to 0, then you will get your two turning points, where we would have in the space of the quadratic, we would have gotten two x values. In the cube function, we will get basically the two turning points. But I haven't really seen something like that. Was there anything like that in the mock exam? Nearly, I have seldom seen a cubic function or any of the other functions that, unless you need to solve x or something like that. So Robin or Norma, I don't, if you guys have gone through the mock exam, was there anything like that in the mock exam or not really?
Not that I can really remember.
Yeah, no, and it would have, you would have remembered it because it's not one of those. So if there is anything on it, it will normally be that you can take one factor out and then work with the rest as a quadratic function. Okay, differentiation. So we actually did a lot of differentiation now already in the previous one. But I think what is important in differentiation is some of the rules. So, and it might be you would have seen in your assessments and in the mock exam that there is normally 2 or 3 questions around differentiation. Um, what will happen is that in study unit 4, we actually did a few of things that we need to differentiate, but there will be a specific question around differentiation. So it might be a combination of the different rules of differentiation. Um, the same on integrations. So again, I think very important. The two goes hand in hand, but that you nearly have the background of the rules on it. And again, you can write the rules down for yourself. So let's go into so nearly what we do in differentiation, and I nearly have showed it now in some of the previous work. But so if this was the function that we needed to differentiate, what we will do is you will take that number, whatever that number is, to the front and multiply it with a constant that was there. So in this instance, we add the 1 just so that, so you will take that to the front. Your differentiation part will then be the 2 times the 1x. What happens here? So whatever, again, this number was, so in this instance, it's 2. We will subtract 1 from it to then get to the next stage. So x to the power of 2 differentiated would have been 2x. Okay, so that is just, again, the we need to a simple function that we work with. We do that if there is things added to that by means of a plus or a minus. Again, we can use the same things. So let's rather go through all the different options. So let me quickly see. Okay, so what we've basically done in that first one now is the power rule. So you can cut this out, you can keep it on the side, but that is the power rule. And the power rule you can use in any equation that has a plus or minus between the terms. Okay, so any term or any that has a plus or minus between it, you can use the power rule. So it doesn't need to be only fixed as one, but the important thing with the power rule is that there needs to be a plus or a minus between the terms, not multiplication or a division. So plus or minus, then we can use the power rule. So if we then differentiate this, it will be the 5 in front, 5 to the power of x, 5 minus 1. Then the second one was a plus, so 3 goes into the front, x3 minus 1. Let's make that x. So minus, the 2 goes in front, 2 minus 1, and then that is a plus, 10 goes in the front, x, there's 1. If there's nothing, it means there's a 1, 1 minus 1. So then your final answer would have been 5x to the power of 4 plus 3x to the power of 2 minus 2x to the power of 1. And here, x, 1 minus 1 is 0. X to the power of 0 is just 1. So that would have been 10 and not 10 to the power of x. So just remember that one when it is x to the power of 0, that actually turns into 1. Okay, so that is the power rule. One more example on the power rule. I think here is some from your textbook as well, but the other one that I really want to show you. So if it was negative, so if there's by any chance something negative, so x to the power of -6, we do exactly the same. We bring that to the front. So it is -6 x. So it was -6 minus 1. So your answer then would have been -6 to the power of x minus 7. Okay, so exactly the same principle. We take it to the front. We then say the -1, so it will then in the end have worked out as -6 x to the power of -7. Okay, so that is the power rule. Let's just get a quick stop in or check in at this point if everyone is happy up until now. Okay. In this, and I think it's all in your textbook, there's a few examples of how to look at it and the differences. Again, we nearly covered all of that in that one example. I think what is important nearly sometimes is when it's something that we're not used to. So something like that, for instance, where it is 1 over x to the power of 2. So we're not used to seeing something like this, but we then just need to put that into a better format that we understand. So that is equal to x minus 2. And then the same process follows. We will take that to the front. It will be minus 2 minus 1. So you would see that is what we would get, like we had with the previous one of a minus 7. Then, dependent on what your answer set is. So if the answers are all given as a fraction, then put that back into a fraction. But I will first look at what my answer set is before I automatically change it into a fraction. So look at what your answer set is to nearly guide you into if you need to put it back into a fraction or not. Okay, so the same with other ones that we know we can use the power rule. Again, always try to put it in the simplest format first. So if I had nearly something like this, then I would put that first, or I will simplify it. I will not go into one of the other rules and try to solve it, because then you just make it very complicated. So I would first simplify that, and then I would use the rule that needs to happen. So by simplification, I could have said, okay, 2 goes into 2 ones, 2 goes into 6 3 times. So at the top there's 3, x go into their ones. If I take 1 away, I'm left with x to the power of 2, and then you differentiate that. Please try to simplify before you differentiate. Otherwise, it really becomes a very difficult problem nearly to work with. Okay, so let's get into one of the next sets, and that is if you need to differentiate exponential or logs. Again, nearly that is the function. So when you look at it, you nearly don't, you guys don't need to solve it or to prove it or anything like that. So when you see it, you can say, if I differentiate anything e to the power of 10, my answer will be e to the power of 10, or will it? So let's look at this example. And so if it is e to the power of x, the differentiation of that will be e to the power of x. If we get e to the power of ax, my answer will be that constant will go in front, but it will also stay there. So if I had e to the power of 10x, my answer would have been 10 e to the power of 10x. Okay, one of those weird ones. We don't need to know why it is like that. We just follow the rules around that. The same if we're looking at logs, or sometimes they call it log, sometimes we speak about it as ln. So when we differentiate that, so if we differentiate ln of x, it will be 1 over x. So if it was ln of 5x, it will be 1 over 5x. Okay, so we must just, these are basically two ones that is important. What they can do is combine some of these into one question that you need to solve it. The other one that is very important is the chain rule. And again, with the chain rule, what I think one also, what is critical here is that sometimes they can give you a question that you might think it's the chain rule, but if you first simplify it, you can use the product rule. But with a chain rule, and how I normally look at it is, and how I want nearly to simplify it for me is, whatever your function is, you basically look at the top one, you differentiate the first one, then you multiply it with the differentiation of 1 over the second one. So nearly when you look at it, and we will look at one of these, yes, we will look at one of these so that we can just show it in a format to work it out. So we will look at that option, that fourth one, just to see how it was done. So the function that we're looking at is y is equal to 1 over x plus 7. So what we normally would do is say, okay, what is your inner function? So your inner function is the x plus 7. So that x plus 7, we would say that is now your inner function. Okay, so you can see now we have, what we have there is 1 over u. Okay, so 1 over u is the same as u minus 1. Okay, so if we differentiate that, we get minus 1u minus 2. Okay, so again, we don't need to add that. So we've got minus 2 or minus u to the power of minus 2. And then the thing that we then need to add to that portion is to say, well, we differentiate the inner function. So that was the one that we did. We differentiate the inner function. So if we differentiate that, remember there's a 1. So that goes in front, becomes x1 minus 1, which is x0. X to the power of 0 is 1. So it's going to be 1 minus, 1 times 1. Anything that if we differentiate a constant, it disappears. So that just disappear. So we basically then have the first function. Here was the second function that we differentiated. We need to say function 1 times function 2. It's minus u over that times 1. So it stays like that. So now again, let the answer set guide you so that you can replace the x, the u with the one that we had at the top. So that might be one of your answer sets. Or if it is that we want to see it as a fraction, we can then write that as a fraction. If I want to see it as a positive fraction nearly, we can write it as that. But please, again, when you look at your answers that they're giving you, let that nearly guide you into what you want to get to, because a lot of times they can give you both options. Okay, let's rephrase it. Not both options. They can give you, in the set of 4 or 5 options, they can give you this type of view or this type of view. So that's why nearly just let those options guide you into what you are aiming for, because you don't want to go this full route and then you don't see it because it's written in one of the other formats. So specifically with differentiation, just make sure that what the answer is the format that you're looking for. Okay, so every time that we doing this and where we look at the chain rule, what you're basically doing is you differentiating the one, you differentiating the second one, and you are multiplying the two by one another. Okay, so in essence, that is what you're doing with the chain rule. Um, the thing that can be different is how difficult the function, or what we call the inner function, is. Um, that's nearly what can be the most difficult, is what that inner function is. Again, it won't be a big quadratic function or anything like that. It will be some a more simpler 1x with it will not be suddenly now a quadratic or cube function that you need to work with. Okay, so basically there is the product rule, that is the simpler one that we also use a lot when we need to work out total revenue and those kind of things. Then there is two set of rules that is nearly set in stone. That's the exponential one and the log one, which is really it is what it is. There's nothing else that you can simplify out of it. And then you've got the chain rule, where you need to remember what you're basically doing is you differentiate for one function, you differentiate the second function, or as we call it, the inner function, and then you multiply the two together. Okay, so if we looked at this instance, at this one, we would have said, okay, my inner function is 2x plus 3. Okay, so the one function that I differentiate is then, and they like to call everything u, so let's call it u. So that would have been your first function that you want to differentiate. So 5 goes to the front. So 5u, 5 minus 1, 5u to the power of 4. So there we have it. The other one is with 2x plus 3. So we want to differentiate 2x plus 3. So we know that there's a 1. 1 times 2. And then it's x 1 minus 1. So we actually end up with 2. Then again, we multiply the two together. So it's 2 times 5u to the power of 4, which is 10u to the power of 4. And then we replace the u. That will be nearly your final answer. You will not now need to work out the to the power of 4 what it is. So again, let the final answer nearly guide you in what you need to do. So you've got this. All that I would do is replace the u then back with the 2x plus 3, but also check what they do. Sometimes they probably won't keep it at u, because you could have defined it as anything else. But I think just look again at what the answer set is. But when you're doing the chain rule, basically you differentiating the the the, the original function. You're differentiating the inner function, and you multiply the two together. Okay, is that explanation of the chain rule, is that making a bit more sense?
Yeah, it does, and it looks much easier.
Okay, okay. Thanks, Norma, for that. Norma, for that feedback. So again, it's just how to look at it a bit differently to make it easier for you guys, because originally, if you look at it, it's a lot, and between all the different rules and things, it really is a lot. And let's be honest, this the way of showing all of this is also not always that simple. So I must say, if I see that, I already nearly want to feel what are they trying to tell me. But basically, differentiate for one, differentiate for other one, and multiply with one another to get to your final answer. And so again, we have a few of them. So let's look at this weird one. So we've got the exponential rule combined with the chain rule. So this was your original function. Um, so again, we will say u is equal to 4x plus 5. Okay, so first let's differentiate e to the power of u. To differentiate that, our answer is e to the power of u. So we still use the exponential rule as we know it in the setting. Then the second one is to say, but okay, we've got 4x to the and plus 5. We need to differentiate that. So the only thing that happens here again is the 4x will become 4. Then we say, well, we need to multiply the two together because that is what the chain rule says. So out of that, my answer then will be 4 times e to the power of u. And then we can just substitute that u back. So it is 4x plus 5. Okay, so again, something that originally looks very difficult. But if we use again here the chain rule, we can solve the answer. So that again for me is nearly a way that one can look at it to make it simpler for yourself. Okay, questions on this? Okay, so let's look at what else is there. So the last one is the product rule. Okay, so the product rule again, and let's nearly try to make it simpler. So the product rule, when what this is saying is you've got two functions. So you've got the one function, you've got the second function. So what you do is, and the order does not matter as long as you follow the rules. So you can have it as you take the first product, you multiply it by the differentiation of the second one. plus, when you just swap it around, you take the second one times the differentiation of the first one. So here you can see it doesn't matter which one is first and which one is second, as long as in the first one it is one term times the differentiation of a second term, and in the second grouping it is the opposite. So when it is the differentiation of the other term times the first term. Okay, so if we look at this, so here's your one term, there's your second term. So it should have been, when I take my first term and I multiply it by the differentiation of that. So that would be 2 to the power of x. Okay, so that is my first one sorted. I plus that by saying, okay, my second term times differentiation of ex. We know that differentiation of ex stays ex. Okay, so this is a weird one because it seems like you did the same thing, but it is just because we're working with ex. So you can see what they did is they did it first, this one, then the other one. It does not really matter which one you do first, which one you do second, as long as you do both of them. And then again, guide you by what is the answer set. So sometimes that might be one of the final answers, but it might also be that they just say, okay, wait, where did I make a mistake here? I took the wrong, sorry, I took the wrong. So guide by what is, so if they want two factors on it, you can do that. So again, you would see I will then write it out in from highest to lowest, but it doesn't really matter. And they will not go into another set where they try to factorize this. So you don't need to worry about that. So sometimes that will be your last one to look at. Sometimes they will say, but okay, maybe you could have simplified it a bit more, but they will not want you to factorize that into another two brackets. So again, nearly showing that you can end there. Okay, so we've done product, we've done chain, we've done what was the first one? Nearly forgotten about the power. So power, product, chain, logistic, and exponential. So those are the 5 rules that we work with, and then it can be in a combination of different things. The last one is the, and again, excuse how I pronounce it. I call it the quotient rule. If you pronounce it different, that is also fine. And what we have here is when we divide two functions. But what is important is that it's not something like this. So it's not when it is x squared divided by x. This you can simplify. But if you had this, you can't simplify it. So be very careful in the exam that they give you something like this where you can actually simplify and get an answer, and you go and try to use the quotient rule, because you will probably in the end get to the same answer, but it will take you nearly 10 minutes longer. So really be really very careful, specifically with the quotient rule, that what the two nearly functions are, that you can't just simply simplify it. Okay, so then if we need to work it out, in this one, there's very much big structure in it. If you at all change the sequence of it, it will give you a different answer. But the easiest, how I always remember it, is you take the differentiation of the top one. So let's say I'm just using numbers. So let's say the top function was 1, the bottom function was 2. So differentiate the top one times the bottom one minus the top one differentiated by the bottom one. And you divide everything by the square root, or this to the power of the bottom one. Okay, so very specifically, you need to follow that structure for this. So let's look at a function like that. So here we see the top one has 3. We can't simplify anything at all. So for this, we need to use the quotient rule. So it is differentiation of the top one, which is 2x plus 2 times whatever the bottom one was, minus then the top one why does it not want to get that out of the way? So it's the top one times differentiation of the bottom one. And that then is divided by the bottom one to the power of 2. So if we look at what, it's exactly the same as on this side. Okay, so then you need to multiply out, and again, please, you don't need to look at factors or anything like that. That will be your last answer. If it was, let's just make it something weird now. Let's say it was this. So let's say that that was the thing that you needed to say that was fx. So if that was fx, we would have said, okay, but let's first see what we can cancel out, so that you don't go into the quotient rule. So at the top, there's x squared. What is left in that is a x plus a 1, or sorry, plus 2. At the bottom, there's x squared, or x to the power of 2. So that could have cancelled out. So my fx was actually x to the plus 2. And if I then need to differentiate that, my answer is as simple as x being differentiated, which is 1. But if you now went through this whole process, the chances is that you probably would have gotten to the same answer, but you would have done a lot of calculations nearly in that process. So for me, whenever you need to do the quotient, just be 100% sure that it is what you need to do. And that is nearly the end for the differentiation. I think this one is probably the most difficult to remember, and the one that is probably the one that catches one out the easiest, because when you nearly see something is being divided, you nearly want to go into this rule already, and sometimes just make 100% sure that there is not a simpler way of doing it. Okay, did that at least assist you guys a bit better for the exams? Does it make it a bit simpler? I'm just going to stop the recording